symmetric circuit in the last class. Okay. And we had done this sum. Okay. We had solved these sums. So after solving the sum, okay, we had seen the sum by writing the potentials, finding out the potentials of every point, and then we had tried to solve this. Okay. Now, after doing that, we had done this sum also. Okay. We had done this one. This was mirror symmetry. Okay, this was mirror symmetry. So just let me know whether we had completed this or we had just started. Yes, just let me know whether we had started this or we had just finished this thing. Yes. Okay, this we have completed. Fine. So I'll take one more problem. Okay. One person is writing just started. One person is writing completed. Yes. If you are having doubt I will take. But let me know whether I have explained this or not. Using mirror symmetry, did I explain this or not? Okay, I already explained. Good. Fine. So, us to do the book example. Okay, that book problem you do. Okay, yeah. Now I got. Okay, where did I leave? Fine. Now, we will do one question on this. Okay, we'll do one more question on this. Okay. Now, suppose the next circuit that I'm giving to you is it is like this. Okay. Fine. This is the circuit that is given to us. Like this. This is A point, this is B point. Now we are asked to calculate the equivalent resistance. We are asked to calculate the equivalent resistance across point A and B. We have already done this. Oh, we have done these sums. We have all okay. This also we have done. This is batch 1 only, no? Yeah. Okay, 2. Sorry. Yeah, we have already done all these sums. Okay, I'll look for another problem then. Okay. So this also we did, this also we did. Yeah, we have done almost all kind of problems. Okay, we have covered almost all kind of problems. Now just let me know whether we have done this, you have done this or not. It looks I have also explained this also. Okay, so if you are having any doubt, you can ask now. Okay, this topic is completed. This topic is completed. I'm going on to the next topic. Okay, do it quickly if anybody is having any doubt. We just cleared now itself. I'm going on to the next topic. Yes, I'm going on to the next topic. If anybody is having any doubt, you just ask now. Okay, current values you just match from the book. Current values you just match from the book. I don't have the answer. It is already solved in the book. Okay, NCRT book. This is a solved example. Okay, Now I'm going to the next topic, which is grouping of cells. Okay, next topic is grouping of cells. Okay, grouping of cells. Okay, now in this grouping of cells, like we have done for the resistors, right? Like we have done for the resistors, we'll do the same thing for the cells now. Okay, so suppose if I give you cell, okay, if I give you 2 3 cells, so a cell will be having EMF also and resistance also. Okay, so let us see that first. Okay, about the ideal cell. What is ideal cell? Let us first see about the ideal cell. So ideal cell has no internal resistance. No internal resistance. Okay, internal resistance is what we have already covered. We have already covered almost half an hour on that topic. Okay, internal resistance. No internal resistance. Real cell, real cell, they do have internal resistance. Okay, so they do have internal resistance. Internal resistance. Okay, they do have internal resistance now. Okay, so this is ideal cell, and now what we will be talking of, what we will be talking of is the real cell. Okay, real cells, combination of the real cells. So suppose this is one cell we have. Okay, this is the second cell we are having, and suppose this is the third cell we have. This is the third cell we have. Okay, so now if I ask you, just connect them. If I ask you, how will you connect them? So what you're going to do, you are just going to connect these cells like this. Okay, you'll just connect this one like this. Then you can connect this cell like this. Okay, and if you have more cells, so what you will be doing, you'll just connect like this, and so on. Fine, you'll be doing like this. Now suppose if this cell is having EMF E1, E2, okay, these are having EMF E1, E2, E3, E4, and so on. The internal resistance value is R1, R2, R3, and so on. So these are the values. Now, suppose I want to ask you, what is the equivalent EMF? Okay, equivalent EMF. Okay, if I want to ask you, what is equivalent EMF now? So what you will be doing? You will be just adding all of them. Okay, you'll be adding all of them. Why you'll be adding all of them? Because they're connected like that. Because they are connected like that. So what is, how actually I can manipulate the circuit? How can I redraw this circuit? See, I can redraw the circuits like this. Okay, first I can draw all the EMFs, and then I can draw all the resistances. Okay, so you can do that. You are allowed to do this in a circuit. Okay, within a branch of a, okay, within a branch of a circuit, you are allowed to do this thing. You are allowed to manipulate, and you are allowed to then shift the elements as per your requirement. Okay, so if I put any resistance which is in series here and there, so I can do that. Okay, now this is suppose E1, this is E2, this is E3. Okay, the values are suppose 10, 8, 6. So what is the EMF now? Total EMF will be now how much? Yes, it will be 24. Okay, so it is solved like that. Fine. Now, so similarly, equivalent EMF, if you want to give here, so it will be E1 plus E2 plus E3 plus and so on. It goes like that. Okay. If you want to find out, if you want to find out equivalent resistance, okay, equivalent resistance, okay, then what you can do, it will be written as R1, R2, R3 plus and so on. It is like that. Okay, now here just see the the batteries, okay, with their internal resistance, they are connected in an additive sense. Additive sense means what? Additive sense means what? If you remember one example I had given you, okay, if you remember one question I had given you, this was 6 volt, this was 2 volt, and then I had given you an example like this also. So this was 6 volt and this was 2 volt. Okay, so for this what you would have got answer 8 volt, and for this what you answer you would have got 4 volt. So actually when the batteries, when the cells are connected in this sense, okay, positive, negative of one cell connected to positive of the another cell, then negative of that cell connected with positive of the other cell. So this is a additive nature. This is what? Additive nature. Okay. If you connect in the another way, okay, so in this way, so it is what? 6 minus 2, that is 4. And if I want to solve, if you suppose want to solve it, so let us do that also. So this is point A, this is point B. So if you want to write down the potential VA minus VB, what is the potential difference across AB if you want to calculate? So VA is having, suppose, VA potential, then minus 6 volt minus 2 volt is equals to VB. Okay, so this implies VA minus VB is equals to 8. So this is what you will get. Okay, so these all things you have done. Okay, so this is a additive circuit. So this circuit that is in front of you is a additive nature of series connection. Okay, so this is series connection but additive in nature. This is series. Okay, series connection. In that also it is additive. Okay, this is additive. Additive. Okay, now suppose if this is additive, so there has to be a subtractive. Okay, like 6 minus 2, 4. So subtractive, how will you connect them? How will you connect them? So it is connected like this up. See, if this is one battery, this is its resistor. Now this is the battery and this is the resistor. Now just see how you have connected both the things. Okay, how you have connected. Just see how you have connected this one. Okay, this one. Just see how you have connected this. Okay, and how you have connected this. Just see how you have connected this part of the circuit and this one. Okay, so positive connected with the smaller one and the smaller one connected with the bigger one. Okay, so like that it is a additive circuit, but in this way when you do it, so it is subtractive in nature. So this is E1, this is E2, this is R1 and this is R2. Okay, so if you want to calculate equivalent EMF, so it will be E1 minus E2. Okay, and equivalent resistance if you want to calculate, so it is still like this. Okay, now I'm taking one example on this, and after the example, if you have any doubt, you can just ask. Okay, so now I'm giving you a question. We are going to do a question. Now the question is, we have a battery, its internal resistance, then again a battery and its internal resistance. Okay, so suppose this is 10 volt, this is 20 volt. Okay, and this is 2 ohms and this is 1 ohm. Okay, so you tell me what is its equivalent EMF? What is its equivalent EMF? Yes, I want everyone to write it about this. What is the equivalent resistance here? Equivalent EMF here. Yes, it is 30. Good. It is 30 volt. Okay, because they are, it is connected in the positive sense. It is connected in a positive sense. Okay. What is R equivalent? What is R equivalent here? What is R equivalent? 3 ohms. Very good. 3 ohms. Now, if I give you a question, okay, like this. So this is suppose 20, this is 2, this is 10, this is 1. Okay, ohms, volt. You tell me what is equivalent EMF? Equivalent EMF. What is the equivalent EMF? Equivalent EMF is still, sorry. 10 average. Not like this. It is not connected like this. Instead, it is connected like this. Now tell. Now you have to tell. Now you have to tell. Okay. That was wrongly. Now you have to tell. 10. Good. 10 volt. Very good. What is R equivalent? What is R equivalent? Is it 1 or 2 or 3? 3 is still 3. Is still 3. Okay, is still 3. So what I can say now here by looking at these examples. Okay. So if I'm writing this as an important point. Okay. If cells are connected in series, if cells are connected in series, okay, then equivalent EMF, okay, will be given as E1 plus minus E2. E1 plus E2, E1 plus E2 when you have additive nature. E1 minus E2 when you have subtractive nature. Okay, and R equivalent will be R1 plus R2. Okay, so either it is subtractive or either it is additive. It doesn't matter. It doesn't matter. It will always be additive in added. Okay, the internal resistance will always be added only. It doesn't matter it is additive in nature or subtractive in nature. Okay, so now if anybody is having any doubt, you just ask. Now if anybody is having any doubt, you just ask. Now if anyone is having any doubt, you can just ask now. Yes. Nobody is having any doubt. Shall I move to the next topic? Okay. Next is parallel connection. Okay. This was series connection of the cells. Next is the parallel connection of the cells. Okay. So second is parallel connection. Now parallel connection. In parallel connection, what you have to do is the EMFs will be connected in parallel. Okay. Just see how. Suppose if this is a cell, okay, EMF, this is its internal resistance. Okay. Suppose this is E1 and this is R1. Okay. Now similar to this, I'm having one more. Okay. Set again. I'm having one more. Okay. So these are E2. Okay. These are different values only. So this is E2, R2, R3, E3. Now if I give you some N number of resistors, cells like that, now how will you connect them in parallel? So it is connected like this. Okay. So it is connected like this. Okay. So you'll just make sure that this is connected and this one is connected. Okay. And then if I'm giving you N resistors like this, N cells like this, so it will be coming like that. Understood? There should not be any doubt in the way of connection. Now just see here, I'm going to analyze for this. Okay. Suppose I'm having two resistors, okay, two cells connected, okay, and what is the equivalent EMF? And equivalent resistance now across these two. Okay, we are going to calculate that. So let me assume these points as A and B. Okay, A and B. Now, if I assume the potential of A as X and B as 0, okay, what will be the potential of this point and what will be the potential of this point? Are you able to see? What will be the potential of this point over here? Okay, this point over here and this point over here. X. Just see, there is a EMF also. There is a drop in battery also. How will you write the potential? See, from X to that point. Suppose this is A is small a. This is a small b. So how will you write? X minus E1 is equals to VA. This is how you will write, na? The potential of a point, that point. How will you write? It will be X minus E1. For that point B, what you will write? X minus E2. This is how you are going to write, na? We have done a questions on this. Why you are doing like that? Do you understand now? Yes, do you understand it? Fine. So the potential of the point A, okay, potentials of point A. For point A, it is X minus 0. For B, sorry, X not X minus 0, sorry. It is X minus E1. For B, it is X minus E2. Okay, now applying KCL, okay, now applying KCL, okay, at X, okay, what you will write? X minus E1, okay, minus 0 divided by, what is the resistor? R1. Across the resistor, I am applying the KCL. Okay, I am writing all the currents that are passing, going to B. All the currents that are going to B is 0. Okay, so plus X minus E2 by R2, and this is 0. Okay, now if I solve it again, this is minus 0. Okay, like this is equals to 0. Now if I solve this, so what you'll be having, Ex minus E1 by R1 is equals to E2 minus X by R2. Okay, if I take X by R2 on left hand side, see this, can I write it like this? Minus X by R2. Okay, this one, and here I can write it as X by R1 minus E1 by R1. I can write it like this. Yes, so I can take it this here and I can take it this here. Okay, now this term I'm taking on the left hand side, so X minus R1 plus X by R2 is equals to E2 by R2 plus E1 by R1. I'm taking X common from here. Okay, so I'll be having 1 by R1 plus 1 by R2, and this side I'm having E2 by R2 plus E1 by R1. Okay, now what is the value of X now? It is E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So this is the value of X now. Okay, now if this is the value of X, Okay, this is the, if this is the value of X, if this is the value of X, okay, so just see here in the figure that I'm having two resistors, okay, two cells, sorry, I'm having two cells and I got this, the value of X. What is the potential difference across AB now? What is the potential difference across AB? Yes, VA minus VB, what you will write? X minus 0, X only. So this is nothing but the potential difference across AB only. This is nothing but potential difference across AB only. So what is the net potential difference across AB? That X. Okay. Now this I have solved for two cells. This we have solved for two cells. Remember, for n cells, how will you solve? For n cells, if I'm generalizing it, so for n cells, if I want to write, so what you will write? So it will become equivalent EMF. Okay, this is equivalent EMF only. So equivalent EMF you can write as E1 by R1 plus E2 by R2 plus E3 by R3 plus and so on, divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on. This is how you will be writing. For n cells, this will be the equivalent EMF. Fine. Now, equivalent resistance, how will you find? Yes, here in this case, okay, in this case, equivalent resistance, if I ask you, the two resistances R1 and R2, how they are connected? This two resistances R1 and R2, how they are connected? Yes, this R1 and R2, how they are connected? Series or parallel? R1 and R2, they are connected in series or in parallel? Parallel. Very good. So if they are connected in parallel, so for R equivalent, what you will do? R1 plus R2 plus R3, 1 by R3, sorry. So it will go like that. Okay. If, if this is a condition now we are applying, if R1 is equals to R2 is equals to R3 is equals to and so on is equals to Rn, this is equals to R. Suppose we have a value R now. Okay. Now what will be R equivalent then? How will you do? 1 by R plus 1 by R plus 1 by R, how many times? How many times? N times. N times. Okay. How many times? N times will do. So can I write this as R equivalent? Okay, 1 by R equivalent as N by R. Okay, this implies R equivalent becomes R by N. Okay, so R equivalent becomes R by N. So if they are not same, if they are having different values, R1, R2, R3 up to Rn, they are having different values. So this will be the result. Okay, if all the values are same, so this will be the result for equivalent resistance. Okay, for equivalent EMF, okay, equivalent EMF, if you remember this result alone, okay, that is more than enough. Okay, this one, this result. So I'm putting all the three results on your screen. Just see if anybody is having any doubt. The circuit is also in front of you. Okay, the three results and the circuit is in front of you. Okay, now we are going to see the third kind of combination here. Okay, in resistor we had only two type of combination, series and parallel. We had series and we had parallel. Here we are having one extra. That is called as mixed combination. That is called as mixed combination. Okay, so let us see that also. So the next one is mixed combination. The third one is mixed combination. Okay, mixed combination we are having. Now in this, how the cells will be arranged and how the questions will be asked, we have to see that. Okay, so mixed combination means there will be series also. Okay, you'll be having series also, you'll be having parallel combination also. Okay, so let us see. This is the one cell, its internal resistance. Okay, then again one cell, its internal resistance, cell one again internal resistance. So like this we have, like this we have total m cells. Understood? Like this we have total m cells. Now each cell I'm assuming as same EMF E. Each cell is having same EMF E. Internal resistance also I'm assuming same as R. Okay. Internal resistance also I'm assuming as same only. Fine. Now this is one row. This is one row what I have drawn here. Like this you'll be having so many rows. Okay. Like this you'll be having so many rows. Like this. Can you understand? Can you visualize the thing now? And they all will be connected. They all will be connected like this. Here also they will be connected like this. Okay, and like this you are having total m rows. Okay, n rows, n rows. Fine. So like this you will be having some combination looking. So do you understand the circuit now? Do you understand the circuit now? Okay. Now in this complete thing, in this, for first row, this is my first row. This is my first row. Okay. This is our first row. This is our first row. This is our first row. Okay. So for the first row only. Okay. For first row, I'm writing. So for the first row, what is equivalent EMF? Using series concept, what is equivalent EMF? Yes. What is equivalent EMF? M by N by R is equivalent EMF for first row. I'm asking EMF, not resistance. There are M cells. There are not 3 cells. There are M cells like that. There are M cells like that. I have only drawn 3. There are M cells like that. ME. Good. ME. ME is the correct answer. Okay. ME, because M number of cells are connected. So total EMF is M into E. Okay. What is equivalent resistance? For first row, what is the equivalent resistance? What is the equivalent resistance? What is equivalent resistance? They all are connected in series or in parallel? MR. Very good. MR. Good. So this you have calculated for how what? For first row. This you have calculated for the first row only. Okay. So for first row, if I simplify, so what you are saying that you are having a EMF or a battery whose EMF is ME and its internal resistance is MR. So you are saying like that. Okay. For the second row also, okay. For the second row also, what you are having the same thing. Okay, for the second row also what you are saying, you are having the same thing, so you will connect it like this. Okay, for the third row also you are having the same thing, so you'll connect it like this. Third row, fourth row also like that. So like that I will do n times. Okay, I'll do n times. Now you tell me, is it a parallel now? Is this a parallel circuit now? If I connect all of them like this, if I connect all of them like this, yes, is it a parallel now? Yes, it is a parallel. Okay, and if it is a parallel, you tell me what is equivalent resistance. What is equivalent resistance now? Yes, how will you calculate? They all are same. See, all of them are same. All of them are same. So if I want to find out equivalent resistance, very good, Deepika. Very good. MR by N. Balaji, very good. MR by N. Very good. I got direct answers. Very good. So 1 by R equivalent, how will I write? I will be writing it as M1 by MR plus 1 by MR plus 1 by MR. How many times shall I write this? N times I will write. Okay, so better writing it n times. What shall I do now? MR by N. Okay, this is what I will be having. So this is equivalent resistance now. This is equivalent resistance now. Okay, what is equivalent EMF? What is equivalent EMF? Yes, what is equivalent EMF? Not ME by N. Not ME by N. It will be ME only. It will be ME only. Not NME, it will be ME only. Okay, try to understand how. Try to understand how. You just check this one. You have to just check this one. Okay, first row. In first row, what is the potential difference across the two ends? Across this point, okay, across this point and across this point. Okay, for this alone combination, for one row, what is the potential difference? Is it ME? For the highlighted part, okay, for the highlighted part, what can you say is the this potential difference across the two dots, across the 2 points highlighted? Okay, for the highlighted portion part of the circuit, what is the potential difference now? Yes, is it ME? Is it ME? By XM minus ME? ME only, na? ME only. Yeah, it should be ME only. Huh. ME, good. So if for this it is ME, okay, fine. This is also connected in series with that or parallel with that? These two are connected in series or in parallel? These two are connected in series or in parallel? Yes. They are connected in series or in parallel? They are connected in parallel, fine. So if they are connected in parallel, the potential difference must be same or different? The potential difference must be same, and if the potential difference should be same, so ME for the first one, ME for the third one, ME for all of them, so equivalent EMF will be ME. Equivalent EMF will be ME. Okay, so for this kind of circuit, okay, for this kind of circuit over here, okay, R equivalent, I'm writing it here, R equivalent will be given as MR by N. Okay, equivalent EMF will be given as M into E. Okay, so you have to just, if you observe this result, okay, you will get it. Okay, there's no problem in this. Okay, that it is very hard to remember. Okay, this is very easy thing. So for equivalent resistance, it is MR by N, and equivalent EMF is ME. Understood? Now I'm going to give you a question on this mixed combination. Okay. Now we are going to solve a mixed question on the mixed combination. Okay. So let us do that. If you are having any problem, so we'll address that after this question. Okay. So what is the question actually? That you have this cell, internal resistance, then again a cell, its internal resistance, cell and internal. So you are only having three cells like that. How many cells you are having? Three cells. Okay, not M cells, only three cells I have given is given to you. Now, like this, okay, you are having total of 10 cells, 10 rows. Okay, how many rows you are having like this? You are having total 10 rows like this. 10 rows. 10 rows you are having. And this is what I'm drawing now is the 10th row, the last row. 10th row. Okay. So total there are 10 rows. 10 rows. Fine. Now there is a addition to the circuit from here. What addition? You are having a extra resistance of 10 ohm. Okay. Just try to understand again. Here you are having total of how many rows? 10 rows. Okay. This is one extra external resistance. This is one extra external resistance. Okay. Now each EMF is 0.15 volt. Each resistance is 0.25 ohms. Okay, you have to find out current in the circuit. Current in the circuit. We have to find out the current in the circuit. Okay, just see the question, try to understand the question. Okay, and then we will be solving it. Okay, then we will be solving it. Just try to understand the question once again. So you are having total 10 rows. Each row is having 3 batteries, 3 cells. Okay, each cell is having EMF 0.15. Each cell is having internal resistance 0.25 ohms. Okay, now this complete combination is connected. This complete combination is connected with the external resistance of 10 ohm. So first we are supposed to calculate. For the combination. First we will calculate for this combination. Okay. First we'll be calculating for this combination. Okay. First we will calculate for this combination. So this is 10 rows. Now, what is equivalent resistance? Come on, fast. What is equivalent resistance? For this combination, what is the equivalent resistance? Okay, we'll do for the first row. Okay, we'll first do for the first row. Only for the first row you will tell me. First row. Only for the first row you people will tell me. For the first row, what is the equivalent resistance? Each resistance was 0.25. Each EMF was 0.15. Now tell me what is equivalent resistance? 0.75 ohms. Okay. What about equivalent EMF for the first row? For the first row, yes, it will be 0.45 volt. This is for first row. Now for 10 rows, okay, R equivalent for 10 rows, R equivalent, how much you will get? Will you get 0.075 ohms? Okay, but EMF remains the same. Okay, now I can draw the circuit. This complete combination, this whatever combination you are looking here, I can just modify it that this is having a equivalent EMF and a battery. Okay, so EMF and resistor. So resistance is of 0.075. Okay, ohms and EMF is of 0.45 volt. Now this complete combination, if you see, was connected with a resistor of 10 ohm. Okay, and we were asked to calculate the current. Now tell me, what is R equivalent? Net R. Is it 10 plus R equivalent? It is connected in series. So what will be the value now? It will be 10 plus 0. Okay, 10.075 ohms. Okay, what is EMF? Equivalent EMF is still 0.45 volt. What will be current? Current value E equivalent R equivalent. So it is 0.45 divided by 10.075. Okay, so you will have your answer. Close to 0.44 ampere. Is it okay? Anybody is having any doubt now? Is anyone having any doubt in this problem? Yes, I'll keep it like this. Now. Okay. If anybody is having any doubt, you just ask now itself. I'll keep it like this. Okay. If anybody is having any doubt, you just ask now itself. You take the screenshot of this. Okay. You just take the screenshot. Okay. Now this topic, this grouping of cells is done. The grouping of cells is done. Tomorrow we'll do more questions on this. Okay. And tomorrow I'm going to start voltmeter, ammeter, galvanometer, and meter bridge and potentiometer. That topic. Okay. So that topic is very, very important. So why EMF is same for the 10. Okay. So that topic is very, very important. Fine. So any exam that you write, either it is NEET, if someone is aiming for JEE, if someone is aiming for JEE advanced also, if for board also, any exam that you sit, what we are going to start tomorrow will have at least minimum one question. Okay, NEET people can have two questions also on that. If you are lucky, you may have two questions, but for every exam, at least one question will be there from that topic. Minimum one question. Okay. So tomorrow's lecture, from tomorrow, whatever I'm going to start, it will be very basic. Okay. So tell to your friends also that it is a very important topic. Okay. So don't miss that class, tomorrow's class and coming classes. Okay. Because one question is sure from that area. Understood? So I guess all of you have taken this screenshot. So I'll put grouping of cells. We had started from the grouping of cells today. Meanwhile, if anybody is having any doubt, you can ask. Okay. Why EMF is same for 10 rows? Okay. When I'll go to that page, I'll tell that. Okay. Regarding this page, if anybody is having any doubt about the additive and subtractive nature of the series combination, if anybody is having any doubt, just ask now itself. Okay, I guess you have done this. This is the second slide. This is the second slide. Okay, this is the second slide. This is the third slide. This is the third slide for, okay. Do it fast. Meanwhile, if anybody is having any doubt, you just post it. Stanley, at the end, I will address this. First, take the screenshot. Okay. There's the second, third slide, fourth slide. This is the fifth slide. Okay, and this one you have already taken. Y equivalent and is ME for the series and parallel combination. Okay, let us see now. So few people are having this doubt. Okay, if anybody else is having that doubt, just see. The doubt is that if I'm having this EMF and this is the cell, okay. So if this is E and this is R, and like this, if I'm having a combinations, okay, if I'm having combinations like this, okay, so why is it that I will write E only? I will write E only, okay. So just let us understand with the example now, okay. Let us understand this with the example. So what I'm going to do is I'm going to take a numerical here, okay, a small numerical, and I'll try to make you understand. So this is VA, okay, this is VB, okay. No current. EMF I am calculating. Understand, I am calculating EMF. There is no current. There is no current. Open circuit calculation I am doing. So for open circuit calculation, okay, when no current is there, no current, okay. So what is VA minus VB? We have to calculate VA minus VB, okay. Now you tell me. So VA, if I start calculating it here, so what will be VA minus VB? So VA minus E. There is no drop across R. Why? Because there is no current flowing. So now it will be equal to VB. So what is VA minus VB here? Is it equal to E? Yes. Is it equal to E? Yes. Okay. So this is what we have done for the first row. This is we have done for the first row. Okay. Now I am taking the second row. Now I am taking the second row. Now instead of B and A and B, I am taking C and D. Okay. This is C. This is D. Okay. They are connected. They are connected. Okay. Now you tell me what is the potential across C minus CD. Okay. What is CD? What is this value? We have to calculate that. So let us do here. VC minus, okay, VC minus E is equals to VD we will get. Okay. So VC minus VD is equals to, still it is equals to E only. Just see. Still it is equals to E only. Okay. So this calculation we have done for the D. Understood? So what do you see here? Just see. What are you able to see here now? VA minus VB is E. VC minus VD is E. If I add here, okay, if I make it VE and if I make this VF, what you should get? What you should get? VE minus VF as E only. So across every terminal, okay, we are having a potential difference of E only. Why? They are connected in series, parallel. They are connected in parallel. So what we have studied? That across this end, and across this end, okay, the potential difference must be same. It should not change. That's why you are writing the same potential difference. Okay, that's why you are writing the same potential difference. Okay, this is the reason. Okay, this is the reason why you are writing the same potential difference. If I give you a circuit like this, now, if I give you a circuit like this now, and if I ask you the potential difference across AB and CD, okay, the potential difference across AB and CD, what is the relation? Yes, tell me. For this circuit shown here, okay, what is the potential difference across AB and CD? Are they same? Are they different? Is it same? Is it having same value or are they having different values? Yes, they are having same values. Good. They are having same values. So what is the problem here now? What is the problem here now? What problem you are having here now? The same connection is there, na? What is the problem there? Is there a difference here and here? Is there a difference in this and in this? Yes? Is there any difference? No, there is no difference here. Why there is difference? No difference is there. So if E is here, okay, if E is there, so the potential difference across this point and this point is what? E only. Okay, so there is no difference in this circuit and in this circuit. They are almost same. Okay, so I have given you the slides. Fine. So if you are having any doubt, so tomorrow's class, first 5 to 10 minutes, you just clear the doubts, okay? And then we will start the experiment, okay? The topic related to the experiment, okay? That is very important. Don't miss tomorrow's class and coming classes, okay? And tell to your friends also, if they are not attending the class, so at least they should attend from tomorrow, okay? Okay. So with this, I'll wrap up the session. Thank you.